Match each sequence with its recursive definition. Then, tell if it is geometric or arithmetic. One sequence will not have a match. For that sequence, write a recursive definition that could represent the sequence. Which recursive definition matches this sequence? The given sequence is 3, 6, 12, 24. This is a geometric sequence, and function m is a match. The given sequence is 18, 36, 72, 144. Number 2 is also a geometric sequence, and function L is a match. The given sequence is 3, 8, 13, 18. Number 3 is an arithmetic sequence, and function J is a match. The given sequence is 18, 13, 8, 3. Number 4 is also arithmetic, and function K is a match. The given sequence is 18, 9, 4.5, 2.25. Number 5 is geometric, and function G is a match. The given sequence is 18, 20, 22, 24. Number 6 does not have a match, but one recursive definition could be f of 1 equals 18, and then f of n equals f of n minus 1, plus 2 when n is greater than or equal to 2. Finally, when a recursive definition is given, you can write a sequence for it. This recursive definition starts with 3 and then multiplies each previous term by 5. The first 4 terms of sequence H are 3, 15, 75, and 375.